Now let us discuss another example. The question is, discuss the nature of products formed and the mechanism for the addition of HCl on 3-methyl-1-butene. Now we have alkene as a reactant in this case. That means the reaction will be electrophilic addition. See, the thought process should be like, whatever the question is given to us, first of all identify the reactant. Now we know that in this case the reactant is alkene. That means this will undergo electrophilic addition reaction. Now we know that on addition of HCl in the alkene we get haloalkane, and in HCl the electrophile is H+. Now if you remember, I discussed about the mechanism of alkene with HX. So what happens is, in this case again, when pi electron cloud of the alkene attacks on the H+, it will form basically CH3, CH3, CH positive and CH3. Now basically this carbocation is a 2-degree carbocation. Now because in the question it is given that discuss the nature of the products, not a product, it is products. That means two products will be formed. So now what happens is, two possibilities are there in this case. This carbocation can either undergo rearrangement or Cl negative can attack on this carbocation formed. So if Cl negative attacks on the carbocation formed, then the product will be 2-chloro-3-methyl-butane. Now second possibility is that the 2-degree carbocation formed can undergo rearrangement from its adjacent carbon. So in this case, if H+ shift takes place from the second carbon, then the carbocation formed will be CH3, C positive, CH3, CH2, CH3. Now on this carbocation Cl- will attack. So what we will get is product, that is 2-chloro-2-methyl-butane, whose structure is this. Now the next question we have is that predict the major product of dehydrohalogenation of 4-bromo-1-hexene. Now as the question says, we have to carry out dehydrohalogenation. So now we have to think first of all whether E1 will take place or E2 will take place. In this case, as it is not given that what is the base, so we cannot decide easily that it will undergo E1 mechanism or E2 mechanism. But if suppose we carry out E2 mechanism, then there are two possibilities. If you see in this case that on the 4th carbon we have bromo group. So that means what will happen if you carry out E2 mechanism is the base will pick up the hydrogen either from 3rd carbon or from fifth carbon. Now, if the base picks hydrogen from third carbon, then the product formed will be this, that is CH3, CH2, CH double bond, CH single bond, CH double bond, CH2. This is known as hex 1,3-diene. If suppose base picks up acidic hydrogen from fifth carbon, then the product formed will be then CH2, CH double bond, CH2. The name of this compound is hex 1,4-diene. Decide which is the major product. In this example, basically we cannot decide using the concept of Sedgwick rule, because in both the products formed on the carbon double bond carbons, we have same number of H atoms, that is 2. So therefore, in this case, Sedgwick rule is not applicable. So now we have to think about other factor of stability also, which will help us in telling which is the major product in this particular reaction. Now the first product is basically a conjugated product, and the second one does not have any conjugation. That means the first product will have a resonance stability, whereas a second product does not have. Therefore, we can say that first product will be the major product and second will be the minor product.